In the vast, unending darkness of space, stars shimmer as distant points of light, silent witnesses to the passage of time and the motion of worlds. Yet, occasionally, amidst this cosmic stillness, a traveler appears. A visitor from beyond, a messenger from a distant star system. In the early summer of 2025, astronomers on Earth witnessed just such a visitor. It moved silently through our solar system, a faint, enigmatic object on a trajectory that could not have been predicted. Its name was 3I Atlas, a label technical and understated, but one that carries the weight of billions of years of cosmic history. This is the story of that object, a relic, a messenger, a fragment of another star system that has traveled across the galaxy for longer than our own Earth has existed. The journey began on a cool night, July 1st, 2025, in the remote Rio Hurtado Valley of Chile. There, a small 20-inch telescope, part of the Asteroid Terrestrial Impact Last Alert System, or ATLAS, was scanning the night sky. ATLAS, funded by NASA and operated from the University of Hawaii, had a simple and vital mission: to detect objects in near-Earth space that might someday pose a collision threat. Its instruments had discovered thousands of asteroids and comets since 2015, but that night, something unusual appeared in its field of view. It was faint, a mere speck against the velvet darkness, but it moved with a velocity unlike anything orbiting the Sun. Within hours, astronomers realized that this was no ordinary near-Earth object. Its trajectory was hyperbolic, too fast to be captured by the Sun's gravity. This was a visitor from beyond, only the third interstellar object ever recorded to enter our solar system. The first, Oumuamua, in 2017, had startled scientists with its elongated, tumbling shape and mysterious acceleration. The second, 2I Borisov, discovered in 2019, resembled a familiar comet, yet carried subtle signs of a foreign origin. And now, in 2025, 3I Atlas had arrived. Recovery images from mid-June 2025 were soon identified, extending the object's observational arc and allowing astronomers to refine its path with unprecedented precision. The object was moving extraordinarily fast, approximately 130,000 miles per hour, hurtling toward the inner solar system, a relic traveling for perhaps 7 billion years or more. An ancient fragment from a star that formed long before the Sun itself. Its origin, scientists believe, lies within the Milky Way's thick disk, a region composed of old metal-poor stars, a place of quiet cosmic antiquity. Here, in this outer layer of the galaxy, 3I Atlas had likely been forged, ejected from its home system, and sent adrift into interstellar space. As soon as its interstellar identity was confirmed, observatories around the world pivoted to follow it. The Very Large Telescope in Chile, the Hubble Space Telescope, and the newly operational James Webb Space Telescope trained their eyes on this fleeting visitor. Hubble captured its initial images, revealing a small, hazy body surrounded by a faint coma of gas and dust. The nucleus itself, measuring no more than 1.7 miles in radius. Its comet-like appearance was subtle at first, a glowing cloud emerging from the nucleus as sunlight began to warm its surface. This distant object, so far from the Sun over 4.5 astronomical units away when first observed, was already displaying activity, a sign that its icy materials were sublimating and forming a tenuous envelope around the solid core. The chemistry of 3I Atlas proved even more extraordinary. Observations from the James Webb Space Telescope revealed a coma dominated not by water vapor, as is typical in comets within our solar system, but by carbon dioxide. The ratio of CO2 to water was among the highest ever measured, reversing the typical pattern where water dominates cometary outgassing. In addition to carbon dioxide, trace amounts of carbon monoxide, methane, and other volatiles were detected, yet their quantities were dwarfed by the sheer abundance of CO2. Such a composition suggests that 3I Atlas may have formed far from its parent star, beyond the so-called carbon dioxide frost line, where CO2 ice is stable and abundant. Alternatively, its surface may have been altered during billions of years of exposure to the cold and to cosmic rays, forming an insulating crust that favors the sublimation of CO2 while suppressing water vapor. Either way, it represents chemistry that is alien, a fingerprint of a planetary system that is not our own. Even more surprising was the detection of nickel in its coma, with little to no accompanying iron. In our solar system, nickel and iron almost always appear together in cometary materials. The presence of nickel without iron suggests that 3I Atlas contains unusual chemical compounds, possibly including nickel tetracarbonyl, a volatile molecule that decomposes under ultraviolet light to release nickel and carbon monoxide. Such compounds may explain both the observed nickel signature and the early activity of the comet, even while it remains far from the warmth of the sun. These findings hint at a chemical environment that is fundamentally different from anything we have observed closer to home. For billions of years, 3I Atlas has drifted through the interstellar medium, passing through regions of near absolute zero, bathed in cosmic radiation, perhaps encountering the remnants of exploded stars, clouds of dust, and the faint glimmer of newborn systems. It is a traveler marked by time and distance, a silent witness to the formation and evolution of countless stellar neighborhoods. Now, in a brief moment, it enters the realm of human observation, allowing us a glimpse into chemistry and physics beyond the solar system. The object's trajectory will bring it closest to the Sun, its perihelion around October 30th, 2025. At that point, it will pass within roughly 1.4 astronomical units, just inside the orbit of Mars. Scientists expect that solar heating will enhance its activity, triggering the sublimation of water ice from the nucleus, producing a brighter, more extended tail. Observatories across the globe will monitor this process, recording changes in composition, brightness, and dust production. Observations will reveal how the nucleus responds to the sun's energy, how outgassing evolves, and whether deeper layers of material, preserved since its formation, are exposed. The nucleus, still obscured by its expanding coma, may finally be measured directly by Webb and other instruments, providing critical information about the size, mass, and density of this ancient traveler. Compared to its interstellar predecessors, 3I Atlas is strikingly different. Oumuamua, observed in 2017, was elongated, lacked a visible coma, and exhibited non-gravitational acceleration that puzzled astronomers. Borisov, on the other hand, displayed comet-like activity with a familiar mix of volatiles including water, carbon monoxide, and minor amounts of other compounds. 3I Atlas, by contrast, is dominated by carbon dioxide, contains unexpected nickel signatures, and lacks iron, a unique chemical profile that challenges our understanding of planetary system formation. As it continues its journey past the Sun, 3I Atlas will eventually return to interstellar space, hurtling outward at its original hyperbolic velocity. For humans, this visitor will be gone, disappearing into the vastness from which it came. But for a brief period, it provides an unprecedented opportunity to study the physical and chemical properties of material formed around another star. Each detection, each spectrum, each photograph adds to our understanding of the diversity of planetary systems and the forces that shape them. It is a tangible reminder that the solar system is not isolated. It is part of a galaxy filled with wandering fragments of distant worlds. Astronomers anticipate that the Vera Rubin Observatory, soon beginning operations in Chile, will detect many more interstellar objects in the coming years. These discoveries will expand our knowledge of the population of wandering comets and asteroids, providing comparative data to contextualize 3I Atlas. Each object may tell a story of its origin, composition, and journey across the galaxy, offering clues to how stars and planets form and evolve in environments vastly different from our own. For the people observing it, 3I Atlas represents more than data points. It is a connection across time and space, a messenger from a distant era, carrying within it the materials and chemical signatures of a star system far removed from ours. Its carbon dioxide-rich coma, its nickel without iron, its journey spanning billions of years, all speak of a universe that is dynamic, complex, and endlessly fascinating. This is a moment to reflect on the scale of time and space, the fragility of our understanding, and the opportunity for discovery that emerges when human curiosity meets the cosmos. As the sun's light warms its surface during its closest approach, the comet will display the unfolding of processes that have been in stasis for eons. The outgassing of CO2, the gradual liberation of water vapor, the changes in dust production, all provide scientists with natural laboratories to study materials formed far from the sun, in conditions unattainable on Earth. By comparing these observations with those of other interstellar objects, astronomers hope to reconstruct the histories of star systems across the galaxy. Ultimately, 3I Atlas reminds us of the vastness and interconnectedness of the cosmos. A fragment ejected billions of years ago from a distant star system has arrived in our solar system for a fleeting moment, visible through our instruments and capable of teaching us lessons about chemistry, physics, and cosmic history that would otherwise be inaccessible. It is both a relic and a messenger, bridging the gap between stars, connecting our planet to the broader galaxy, and hinting at the countless other travelers that drift silently through interstellar space. In the end, the comet will depart, continuing its voyage beyond the reach of human observation, back into the dark expanses of the Milky Way. Yet its brief visit leaves a lasting legacy, a reminder that the galaxy is alive with movement, that planetary systems eject material across light years, and that each fragment carries the memory of its origins. 3I Atlas is a story written in ice, rock, and gas, spanning eons, a narrative of cosmic chemistry in motion. It teaches us that even in the apparent stillness of space, there are journeys unfolding, mysteries arriving at our doorstep, and new worlds whispering their secrets to those who watch the sky. We call it 3I Atlas, but it is much more than a name. It is a record of time, a chemical archive of an alien star system, a fleeting visitor reminding us of the dynamic, wondrous, and ancient galaxy in which we live. And while it will vanish beyond our view for a short season, it opened a window into a cosmos far older and more complex than we had ever imagined. A silent traveler carrying the story of another world across billions of years and light years, arriving to touch our solar system and our understanding of the universe ever so briefly.